Now that you have a strong hub and spoke network architecture with routing, domain name system, and segmentation principles, you are ready to lock in the next layer of enterprise control, private access. This is where you stop relying on hope that public exposure is configured safely and start designing so sensitive services are reachable only through private network pathways. Private access is one of the most powerful ways you reduce breach likelihood, simplify compliance conversations, and make your architecture easier to defend under scrutiny. With that direction set, you need a clear definition that leaders and architects can share. Private access means your workloads reach platform services over private network paths rather than public internet paths. Instead of data flowing out to public endpoints and coming back, your design keeps traffic inside your controlled network boundaries. This is not a cosmetic improvement. It directly reduces attack surface, reduces exposure to internet-based scanning and exploitation, and improves your ability to govern where data can travel. With private access defined, you now clarify the two problems you are solving so your design decisions stay grounded. The first problem is exposure. When services are reachable publicly, even if access is restricted, they become targets for probing, misconfiguration, and identity-based attacks. The second problem is trust assumptions. Public access patterns often assume that identity controls alone will always stop attackers, but real-world incidents show that stolen credentials and session hijacking can bypass weak access design. Private access reduces your dependence on perfect identity behavior by removing public reachability for sensitive services. With the problems clear, you now introduce private endpoints as a building block in your reference architecture. A private endpoint gives a platform service a private network presence inside your virtual network, so the service can be reached through private addressing. Conceptually, this means your workload accesses the service as if it is inside your network boundary, even though the service itself is managed by the cloud platform. Leaders value this because it reduces attack surface. Architects value it because it makes private by default a repeatable design standard rather than a case-by-case debate. With private endpoints introduced, you now highlight the truth that many teams learn the hard way. Private endpoints are only half the story. The other half is name resolution. If your domain name system does not resolve service names to the private endpoint addresses, traffic will still attempt to go to public paths or will fail in unpredictable ways. Private domain name system is what makes private access reliable and consistent across environments. For leaders, this is about reducing outages caused by misaligned name resolution. For architects, it is about creating a stable enterprise pattern that teams can adopt without constant troubleshooting. With that dependency understood, you now frame private domain name system as a governance topic. Name resolution defines where traffic goes, which means it directly influences security outcomes. If different teams manage private domain name system inconsistently, some workloads will be private, while others quietly use public paths, and you lose predictability. This is why the platform team typically owns private domain name system zones and their association to networks, while workload teams consume the standard pattern. It is not centralization for control's sake. It is centralization to preserve consistency and reduce hidden risk. With governance framing set, you now connect private endpoints to your hub and spoke model. The key decision is where private endpoints should live and how spokes should resolve them. In many enterprise designs, private endpoints are placed in the spoke where the consuming workload lives because the private address is meant to be local to that workload network. The private domain name system zones, however, are often centrally managed and linked to relevant virtual networks. So resolution works consistently across the estate. The leadership outcome is clear accountability. Workload teams own their private endpoint usage, and the platform team owns the naming and governance pattern. With placement clarified, you now address a critical architectural risk. Private access does not automatically mean secure access. If your segmentation is weak, private endpoints can still be reachable from too many places inside your network, and you simply move the attack surface inward. Your design must ensure that only the right subnets and workloads can reach sensitive private endpoints, and that east-west traffic controls align to your trust zones. This is how you prevent the common failure where everything becomes private but also flat, making lateral movement too easy during an incident. With segmentation aligned, you now reinforce that private access and identity are complementary controls, not substitutes. Private endpoints reduce public reachability, but identity still governs who can authenticate and what they can do. Strong identity controls reduce the chance of misuse, while private access reduces exposure to the open internet. For leaders, this layered approach reduces the probability of catastrophic compromise. For architects, it creates a defensible control stack where failure of one layer does not automatically collapse the entire model. With the control stack clear, you now talk about trade-offs honestly, because leaders will feel the cost of complexity if you do not manage it well. Private endpoints and private domain name system add design considerations and operational overhead. The way you keep this manageable is through standardization, clear patterns, and strong platform ownership of shared components. If you treat private access as optional per team, complexity explodes. If you treat it as a standard with a paved road, complexity becomes predictable and supportable. This is the difference between a private access program and a private access mess. With trade-offs acknowledged, you now create clarity on where private access must be non-negotiable. For sensitive platform services, regulated data, critical business systems, and shared enterprise services, private access should be the default expectation. You do this because the risk and impact justify the design discipline. Leaders appreciate clear rules because they reduce exception debates. Architects appreciate clear rules because they remove uncertainty and speed design approvals. Your role is to set these boundaries based on risk and business criticality rather than personal preference. With mandatory cases clear, you now set a realistic position on when public access may still be acceptable. Some workloads and services may require internet-facing access for customer use cases, global reach, or integration with third-party systems. In those cases, the architecture decision is not public is bad. The decision is public must be controlled. You define strong identity requirements, protective controls, monitoring, and strict governance for any public exposure. This ensures your private access strategy is pragmatic and does not become an obstacle to legitimate business requirements. With the policy approach clear, you now focus on design principles that reduce operational pain. The most common private access failures in enterprises come from inconsistent domain name system resolution across networks, environments, and hybrid connectivity. Your design principles should ensure that private names resolve privately where intended, that resolution is consistent across spokes that need access, and that hybrid name resolution is aligned so on-premises systems can reach private endpoints if required. Leaders care because name resolution failures look like broad outages. Architects care because consistent name resolution reduces troubleshooting time and makes private access predictable. With domain name system principles established, you now address hybrid reality because many enterprises are not cloud only. If on-premises systems must reach Azure platform services, you need a consistent approach to private connectivity and name resolution across the boundary. This is where your hub connectivity strategy and your domain name system integration strategy must work together. The leadership concern is continuity. Business processes often span cloud and on-premises environments. The architectural concern is consistency. Hybrid name resolution and routing must be deliberate, not accidental, or you create fragile dependencies that fail under change. With hybrid implications understood, you now define operational ownership, so your private access strategy scales. Platform teams typically own private domain, name system zones, linking strategy, and governance standards. Workload teams own consumption, meaning they request or adopt the private endpoint pattern for their services and ensure their workloads align with segmentation rules. Security teams own policy expectations and monitoring outcomes. Leaders value this because it prevents ambiguity during incidents and audits. Architects value it because it prevents private access from becoming a distributed, inconsistent practice that cannot be governed. With ownership clear, you now ensure you can measure whether private access is actually being used as intended. You design monitoring so you can detect when workloads are still using public endpoints, when name resolution is failing over to public paths, or when access patterns look unusual. This is not about surveillance. It is about assurance. Leaders need confidence that the private access strategy is delivering risk reduction. Architects need feedback loops so the blueprint improves over time rather than drifting silently. With monitoring in mind, you now ground the topic with a realistic scenario. Imagine a team deploys a data platform that stores sensitive customer information. Without private endpoints, access to storage services may be exposed to the public internet, and a single misconfiguration or stolen credential could result in data extraction from anywhere in the world. With private endpoints and private domain name system, the service is reachable only from your controlled networks, and segmentation limits which workloads can reach it. Even if credentials are stolen, the attacker still faces network containment barriers. This is how private access changes outcomes. It reduces the number of ways a mistake becomes a breach. With the scenario clear, you now frame private access as a leadership asset rather than a technical enhancement. Private access supports compliance requirements, reduces attack surface, and improves confidence in cloud adoption. It also reduces future costs by preventing security incidents and reducing complexity through standardized patterns. When leaders see private access as part of governance and risk management, it becomes easier to fund, easier to prioritize, and easier to enforce consistently across teams. Let's now discuss the key takeaways from what you learned so far, so you can design secure private access in Azure with confidence. Private access is a strategy that keeps sensitive service traffic inside controlled network boundaries, reducing public exposure and lowering attack surface. Private endpoints provide private network presence for platform services, and private domain name system is essential to make that access consistent and reliable. Private access must be aligned with segmentation, so you do not create a flat internal network that enables lateral movement. Identity and private access work together as layered controls, reducing dependency on any single defense. Strong governance, clear ownership, consistent domain name system strategy, and monitoring are what make private access scalable across many teams and environments, including hybrid scenarios. If you want your Azure platform to be private by default and defensible under real-world threat conditions, subscribe so you can continue through the rest of this playlist and build the full enterprise architecture step by step. Like this video so more leaders and architects learn how to reduce attack surface with private access, comment with your biggest private endpoint or private domain name system challenge, and share this with your team so you can standardize secure private access patterns across your organization.